Hey everybody, we're going over some strategies here to try to figure out how to start these FRQs and to scrap for as many points as possible. So remember, what you want to do is read through the whole question and try to figure out what is the key unknown in here. So go ahead and hit pause, read through there and identify the key unknown. So the key unknown in this one is total mechanical energy. We're trying to figure out, is it increasing, decrease, or constant for each of the systems? So that's our key unknown. So what are the flags for big ideas, big concepts in here? So obviously energy is a big one, and we have systems in there. And so energy systems, springs. So I'm actually going to go searching for some ideas in my equation sheet here. So I've highlighted all of the equations that have to do with energy. So let's take a look. See which ones apply here. So potential gravitational energy, definitely could. Spring potential, and this one definitely could. There's springs there. Rotational potential, or sorry, kinetic energy. No, nothing's rotating there. So kinetic energy of an object, yes. Change in the energy, work, forces times distance, yeah. So total mechanical energy here, definitely have work involved there. Power, not so much for this problem. So now we can go back and frame the problem a little bit better. So those are the connections that we have to total mechanical energy here. So I'm going to think about this in terms of total mechanical energy, and I'm going to use kinetic energy plus potential energy plus work is how we have defined total mechanical energy. And so I need to think about these in terms of the systems. So system 1, system 2, and system 3. So for system 1, that is only the block, right? So system 1 is the block only. So can the block have kinetic energy? Yeah. We're not talking about the potential energy of the block here, right? So when we release the block and it's moving upwards, we're not so worried about that. We're just talking about the block as a system, because we're not talking about the Earth as a part of the system. We're not talking about potential energy, gravitational. We're not talking about the spring energy. So we're forgetting about that when we're just talking about the block. So the Earth system is what provides the gravity there. So in system 2, we're talking about the block and the spring system only. So if I'm just thinking about the block and the spring, what kinds of energy are there? There's going to be kinetic energy for the block. There's going to be potential energy for the spring. The Earth is not a part of the system, so there is no gravitational potential. And then system 3, then, now we're including the Earth. So we have the kinetic energy of the block, we have the potential energy of the spring, and now we have potential gravitational energy involved. So now we're moving on to trying to figure out increasing, decreasing, or constant. That's where this idea of work comes in. Work is caused by forces, outside forces on a system. So let's think about the first system as just the block. And remember, it's after the hand lets go. So we know the block is moving upwards. So an outside force from the spring, an outside force from the body. So the net force on this thing has to be upwards, right? Because the motion is upwards and it's accelerating. So we know in this case that since this is 1/2 mv squared, so the velocity of the block is increasing, then the energy is increasing here as well. So now let's think about the energy for system 2. So system 2 is the block and the spring as a system. Remember, we don't care about internal forces there. So the force of the spring on the block doesn't count here. So what do we have? We have the force of gravity on that system as the outside force. So we have these two plus work, right? Because force of gravity is doing work. So because the force of gravity is opposite the direction of motion, right? The block is moving upwards. That is a decrease in energy. So we're increasing in energy in the first one. We're decreasing energy in the second one. What about the third example? So the third example is, remember the hand's not included in this because we've already let go of it. So we have the earth, we have block, and we have the spring. So that encompasses all of these energies. There is no outside force on the system then, right? Everything else is an internal force. So no outside forces, it's going to be constant. No work is being done on the system. So the energy is constant in the third system. So not an easy problem, but looking through here and identifying the key unknown, making those connections by finding equations, understanding if it says total mechanical energy, you write out that equation and you think about it in terms of, is there kinetic energy? Is there potential energy? What is the work? What are the outside forces? And then in terms of a system, make sure you're identifying the system. Okay, for each of these, you're just identifying what's the system, and therefore, what are the outside forces that could be causing work. Good luck.